The Nintendo DS is one of the first touchscreen handheld game consoles which was mass-produced by Nintendo in 2004. The lower screen is equipped with the touchscreen technology to allow users to interact with in-game elements in a more direct fashion. In 1983, Hewlett-Packard came out with one of the first touchscreen computers. The detectors were located in small holes within the computer screen which would sometimes fill up with dust and other dirt, causing the touchscreen to fail relatively quickly. In today's world, we see touchscreen technology all over. The above picture shows a group of women playing a game in Vegas on a touchscreen computer. This system also allows people to order drinks, see schedules of shows, purchase tickets, and flirt with other users at similar tables. This is a prime example of a system that sometimes causes finger stress. ATMs are very commonly used and therefore need a screen that can handle the frequent use and will not activate if something small hits it from bad weather. This means creating a screen that requires a little more pressure from the human hand to activate. Since most phones do not come with stylus, people have had to figure out a way around the fat fingering problem that comes with such small keyboards. One solution has been to shape a fingernail into a point, allowing the user more accuracy when operating their small electronic devices. Many companies have not considered the disabled when implementing touchscreen technology. In the first picture, you can see a man having trouble reaching the screen. Some places have countered this with either placing a lower screen or one that can be shifted downwards so all customers can access services. Self-check-in kiosk at airport in Hong Kong, China. These type of kiosks are very common in the United States, but are not usable by blind travelers. Instead of being able to quickly check in, these people have had to wait for an agent to become free. Airports could easily solve this problem by implementing an audio system or a tactile keyboard to the kiosk. Touchscreen development is booming since the introduction of smartphones and handheld touchpads. The main players in the touchscreen development world are Apple, Google, and HP. The iPhone iOS is developed in Apple's own programming language called Objective-C. It is also an object-oriented programming language, much like Java and C++. The main program used to program iOS is called Xcode, and comes bundled with the new operating system for Apple, OS X. Google's own touchscreen operating system is called Android, and it's giving the Apple iOS a run for its money. Since the introduction of the Android operating system, the everyday American now has access to the touchscreen world without having to convert their PCs to Macs. The Android operating system is mainly written in the programming language of Java and is compiled with the Eclipse SDK. Lastly, the Palm OS is the Palm's attempt in the touchscreen game. The Palm OS is being mainly used in touchscreen handhelds. Since HP bought the Palm company, they have made the Palm OS standard on all HP touchpads. Since every HP touchpad will have the Palm OS loaded on it, you can be sure that the Palm OS won't be overlooked. The Palm OS is based on the C++ language and is produced in the WebOS SDK. One of the main problems with touchscreen technology today is that it lacks clear buttons, making it hard for users to press a button. With older devices, there would be a mechanical button that when pressed would perform an action. This method worked well but made the design static with little that could be changed other than some backlighting. The advantage of touchscreen technology is its ability to dynamically change based on the user inputs. This allows the designer to reduce the number of buttons and give them labels that make them easier to understand. This makes for a much nicer user experience. Chris Harrison and Scott Hudson have designed a new technology that bridges the gap between static buttons and touchscreen technology. Their technology uses suction from a vacuum to pull in or push out a semi-transparent latex layer that is fastened to an acrylic template. Each button is cut out of the acrylic template and the vacuum is then connected to produce a change in pressure. When the interface does not want the button shown, the vacuum is set to off and the button stays flat. When the button is to be shown, the vacuum is turned on and the button is either concave inward or outward. Taking the technology even one step farther is Norio Nakamura and his research team at the National Institute of Advanced Industrial Science and Technology. They have created the first 3D touchscreen TV ever. The technology uses the same 3D technology that has been used in the new 3D TVs for around a year now. The only difference is a camera that is added to monitor finger movements. The technology looks at what the person is touching and then changes the picture to represent an object moving or being deformed. This technology will allow users to move objects in 3D as well as pinch, stretch, and mold them. The user will not be able to feel the objects, but the objects will react logically to the user's motions on the screen. Touchscreen technology is taking off in the mobile device market. Some of today's devices include products by BlackBerry, Apple, Google, and Samsung. While there are many devices, there are really only two ways to produce the picture for today's touchscreen. One is to use an LCD filter backlit by LEDs to produce a picture, and the other is to use an AMOLED to produce both light and picture. In the beginning, whether you used an LCD or an AMOLED to produce the picture, you still needed to install an extra component called the touch sensor panel. This touch sensor panel required an extra air gap, increasing the size of the mobile device. In 2010, companies were able to place the touch sensor panel on top of the LCD and AMOLED, and through a certain process they were able to evaporate the panel, leaving only the sensor attached directly to the LCD or AMOLED. The sensor's thickness was reduced to 0.001 millimeters. The resistive touchscreen has two layers that conduct electrical currents. The location of the touch is sensed by the change in the current level between the panels. Surface acoustic wave touchscreens use sound waves that are projected horizontally and vertically across the panel and captured on the other side by a receiver. The capacitive touchscreen is created by placing a coat of electrically charged transparent conductor on a glass panel. Infrared touchscreens use transmitters that send an infrared beam vertically and horizontally across the panel. Receivers accept the beams that are located on the opposite sides of the panel. Optical imaging touchscreens use an infrared backlight which is projected across the panel, and two cameras are placed in the corners of the panel. Acoustic pulse recognition touchscreens use a glass with a transducer at 4 points around the panel. Touching the APR panel produces a sound which is picked up by the transducers and converted into electrical pulses. There are several sources that today's touchscreens have grown out of. The first is the work of Sam Hurst, which eventually led to the company ELO Touch Systems. While at the University of Kentucky in 1971, Hurst designed a device that was supposed to save him time while inputting data into a computer. He used two pieces of electrically conductive paper which were separated by an insulating layer. A needle was placed to the pieces of paper. Using a voltmeter, the voltage was recorded with and without the needle in place, and the change in voltage helped determine the exact position of the needle. In 1973, he realized that this method could be used with screens. ELO Touch Systems got rid of the needle-based device and created one with two transparent, conductive surfaces separated by a small airspace in between. When the two surfaces were pressed together, the location of the touch is determined. This is called a resistive touchscreen. Many say IBM have been working on infrared touchscreens since 1965 using infrared beams that crisscross. As far back as 1953, Hugh Kane developed a capacitive sensor for synthesizing for electronic music. The position of the fingers control the type of sound. A capacitive touchscreen is what's used in the iPhone today.